Welcome back. So last time we were talking about how we can use the valence electrons on the elements to draw the Lewis structure by just writing the element and putting as many dots represents the Lewis structure. For example, this one will have 5 valence electrons, which means it's on group 5A or group 15. So the old system and the new system. One of the reasons we do this is, if you recall, the elements on group 18, the noble gases, that means they would have, besides helium, which is the exception, all others had 8 valence electrons. So for example, krypton will be represented like this with 8 valence electrons, and neon on the same group will also be represented as this with 8 valence electrons. So all the noble gases, except helium, which is only 2 electrons, are going to have 8 valence electrons, and we call them noble gases because they are very stable. So that's what every single element on the periodic table is wishing to do. They want to be stable, so they want to be like the noble gases. So whenever they start combining with other elements, they're going to do whatever they need to do to somehow look like a noble gas with 8 valence electrons. There's something special I need to show you with the metals. For example, let's take sodium. So sodium with, with atomic number 11, it will have 11 protons on the nucleus. Then on level number 1, it will have the maximum 2 electrons. On level number 2, it will have 8 electrons. And then on level number 3, that's why sodium is on period 3, it will have 1 electrons. So when I represent the Lewis structure for sodium, it would look like this. And you will say, well, so you told me that it wants to be like a noble gas, right? So then it would have to look like this. And the answer is yes, but not the way you're thinking, not by adding electrons. What sodium is going to do is going to lose 1 electron, which means this level is empty, and the remaining level have 8. So when we do the Lewis structure, we do not put 8 electrons there. We take 1 electron out, and to show that, we put brackets, and because it's lacking 1 electron, now it's going to be positive. And that's what every element in group number 1 is going to turn to be positive 1 when it's part of a compound. So by not showing any electrons, we're showing that the one that remains contains 8 electrons. So keep that in mind when we start combining these elements. And remember, we learned on the previous chapter with quantum theory that metals tend to lose electrons. And that's what we call metallic character. So what we are going to learn on this part of the lecture is we're going to continue writing Lewis structures, but now we're going to be doing compounds, specifically ionic compounds, where you're going to have a metal combining with a non-metal, where the metal is going to be a cation and the non-metal is going to be an ion. So 2 ions, therefore ionic. And we're going to use that feature to give any 2 elements, a metal and a non-metal, to determine the possible chemical formula by playing with the Lewis structure. So let's do some problems so you can see exactly what I'm talking about. So write Lewis structure for each ionic compound. Ionic, so I'm going to need cation combining with an anion, a metal with a non-metal, a metal with a non-metal. So let's start with sodium. We're going to do every element by itself first. Sodium is on group number 1, so 1 valence electrons. Fluorine is on group number 7, so 7 valence electrons. And as you can see, there's no cation or anion there, but we know that the metals tend to lose electrons. So what we're gonna do, we're gonna take this electron out. That means it just became a positive cation, and that electron was taken by fluorine. So fluorine just gained that electron there. I'm gonna put it with a little bit of color so you can see it better, which means fluorine now have 1 electron too many, which is gonna make it an ion with a negative charge. And now we have an ionic compound, positive and negative. And you can bring it closer together if you like to. And that's how we represent an ionic compound with Lewis structures. Let's do calcium and oxygen. Calcium is on group number 2, so 1 and 2. And oxygen is on group 16, so 6 valence electrons. So oxygen needs to gain 2 more electrons to be like an noble gas. And if calcium loses these 2 electrons, the one that remains, like I showed you with the sodium, is going to have 8 electrons. So that's what we're going to do. We're going to take this electron and give it to oxygen. We're going to take the other electron and give it to oxygen. And let me put it like this so it looks better. So that means calcium lost 2 electrons, so it became positive because it lost electrons, and it became 2 positive because it lost 2 electrons. Meanwhile, the oxygen gained 2 electrons, so it became negative, but 2 negative because it gained 2 electrons. And now let me give you another example with something a little bit more complicated. What happens if I have, for example, let's say sodium oxide? Well, that means I'm gonna have 2 sodiums and 1 oxygen. The sodium is gonna have 1 valence electron. The oxygen is gonna have 6 valence electrons. So the sodium is gonna need to lose 1 electron like a metal to have the remaining one with 8 electrons, which we don't see, but it just became positive. The other sodium is going to have the same thing happening, becoming positive also, and those 2 electrons are coming to, so it's just a transfer of electrons, they're not going out to nowhere. They're being taken by the oxygen, which is going to be really happy now, because now it's like an overgas, and it gained 2 electrons. And if you notice, you have 2 positive and 2 negatives, so altogether this is 0, which is what a compound is. All compounds are always neutral. The old way, you learn that sodium always is positive 1, oxygen is always 2 negative. Remember what we learned like on chapter 3, and then we do crisscross, and we do Na2O, which is what we have just by doing the Lewis structure. So with that information, you can do this problem. And once you finish that problem, let's go and learn something new. So using the Lewis models, basically the dots representing the valence electrons, find out the formula for the compound. Notice that the one we just did, the formulas were given. Now we're just saying you have strontium and you have oxygen. Would it be two strontiums to an oxygen, or would it be two oxygens to a strontium? Would it be three oxygens to a strontium? We don't know. So that's what we need to find out. According to the Lewis structure, how many are we going to need? And this is the way we're going to do it. We're going to say strontium is on group number 1. Actually, group number 2. Yeah, group number 2. So 2 electrons, 2 valence electrons. And oxygen is on group number 6. 1, 2, 3, 4, 5, and 6. So we know if we eliminate both electrons, then the one that we don't see, the one that remains, it's going to be 8 electrons, so it's going to be like an overgas. So if we take those 2 electrons, we can put them here, and this is like an overgas also. And they can match together, so the formula is going to be just like that, SRO. What about the next one? Well, the formula is actually given. I misled you in that. So the formula is given. Let's see if we can prove it. So this one is going to contain 2 lithiums and 1 sulfur. Can that be true? Well, lithium is on group number 1, so 1 valence electron. And sulfur is on group number 6, so 1, 2, 3, 4, 5, 6 valence electrons. So if this one loses 1, we can give it to sulfur. And because it lost 1, it just became plus 1. This one, and the sulfur is not ready. The sulfur still needs 1 more there. This one can lose 1, which makes it be positive 1 because it lost 1 electron. And we can give that electron to the sulfur, which means the sulfur now is complete, but it gained 2 electrons. 1 positive, 2 positive, plus 2 negative, that gives us 0. So that's how we will do that compound there. What about the calcium? So we got calcium iodide. That means we have calcium with 2 iodides. Iodide is on group 17, so 7 valence electrons. Same thing here. And the calcium is 2 valence electrons. So the calcium can lose those 2 electrons, so one of them is gone, and we're going to give it to the iodine. The iodine now is complete, and it gained 1 electron, so we can do that. The calcium still have 1 electron, so let's take it out. So now the calcium have 8 electrons remaining that we cannot see, and that it lost 2 electrons, so 2 plus, and that electron, we're going to give it to the iodine, which is now complete, but it has 1 too many electrons, so it's negative. So as you can see, we have 1 negative, 2 negative, combined with a 2 positive, that gives us 0, which is what we call a compound. It's neutral. So with that said, you should be able to do that. Actually, I cannot believe I did that. I did your daily work. So try not to look at that. I just got confused. Try not to look at that. This is the one I wanted to do, the one with the formulas, right? That happens. Life is life. That happens. So let's do this again. So calcium is combining with sulfur. Calcium has 2 valence electrons. Sulfur has 6 valence electrons. So calcium is going to lose 2 electrons, which makes it positive 2. And those 2 electrons are going to be gained by the sulfur, which makes it 2 negative. So in other words, the formula is 1 calcium and 2 sulfurs, because we were able to complete everything without having to add any other elements. What about magnesium and bromine? Magnesium is on group 2, so 2 valence electrons. Bromine is on group 17, so 1, 2, 3, 4, 5, 6, and 7, 7 valence electrons. Notice that I said group 17, but we only use the last digit. On the old system, it used to be Roman numeral 7, A, so 7 is what we're going for. So the magnesium is going to have to lose 2 electrons to be like an over gas. So we're going to lose this electron and give it to the bromine. The bromine is complete now, and it gained 1 electron, so negative 1. But the magnesium still has 1 electron, so that means we're going to have to get another bromine. Now the magnesium can lose that 1 and give it to the bromine, which makes the bromine complete, but with 1 too many electrons. And the magnesium lost 2 electrons, so 2 plus. So by playing with the Lewis structures until everybody is happy or everybody is like an over gas, we come up with the formula that we need. So that's how we can determine the formula, by bringing as many elements as you need until everybody have the amount of electrons they need by transferring electrons back and forward. So with that said, now you can do the daily work. So find out how many elements from each one are you gonna need. Do not do crisscross. I know that if you say ALS, you know that AL is supposed to be 3 plus, sulfur is 2 negative, crisscross, AL3. Yeah, that's easy. You can do that. But I want you to do it using the Lewis structure so you can learn the thinking behind it. And not looking for the answer, looking for the reasoning process that goes through. So make sure you do all those 3. And then after that, you will have enough knowledge to do that one, tackle this one on your own. And with that, I can say that we took a good look at how to do ionic compounds using Lewis structures, and we were even able to predict the chemical formula by figuring out how many atoms we needed from each one, so everybody had the same amount of electrons that they needed. So that's it for right now. When we come back, we're gonna do the same thing, but we're gonna do it with covalent compounds. Covalent compounds, there's not gonna be any transfer of electrons, therefore no cations, no anions. They're gonna be cooperating. That's what we call them, covalents. So we're gonna see how they share electrons to be like an over gas. So that's it for right now. We'll see you soon with part C.